Hello and welcome to another video on derivatives. In this video, we are going to discuss about the chain rule. So we use chain rule to find the derivative of a composite function, or when we have a composition of functions. Okay. So for example, if we have two functions f and g, and we have the composition of f and g right here, where g of x is the inside function and f is the outside function, then we can find the derivative of this composition in two different ways. The first one, we'll let the inside function be u, and then the outside function becomes a function of u. And then what we do is we'll find the derivative of the inside function with respect to x and the derivative of outside function with respect to u, and then we multiply them. That gives us the derivative for the composition. Another way to do it is we'll find the derivative of outside function and then we multiply that by the derivative of inside function. So basically this is how I usually write this one, and this one is the most commonly used one. We use a lot the second one because it is a little bit kind of like shortcut. Okay, so we do the derivative of outside function, okay, or the outer function times the derivative of inside function or inner function. Okay, so that's how we find the derivative. Let's look at some examples. So we'll do a lot of examples here. So let's go ahead and use the first version, and then I'll show you how to use the second version as well. Okay, so first we are going to use the first version of the chain rule, and then we'll find the derivative. So the first thing that you need to look over here, do I really need to use the chain rule? And then when you look at the function, it should tell you, is this a composition function, and is it really complicated that we cannot use the rules that we have just used so far, okay, the basic rules. So usually basics, so if you think about the power rule, we can use power rule when you have x to the some power, okay, but instead of x, if we have a function raised to some power, then that basic rule does not work. So we have to use the chain rule. Similarly, if you have just the trigonometric function like sine of x, then we have the basic formula. But if you have sine of and a function here, then we really cannot use just the basic formula. We have to use the chain rule. So wherever you have instead of just x, most of the formulas are based on x, but instead of x, you have some function in place of x. That's when it becomes a composition function, and then we use the chain rule. Okay, so once we do some more examples, you'll get used to it, that when to use the chain rule. So for example, over here, if this was just x to the fifth, then we don't need to use chain rule. We could just use the power rule. But instead of x, we have a function here, which is more than just x. So in that case, we have to use the chain rule, okay? So if you are using the first version of the chain rule, what we do is we let the inside function be u. So here the inside function is 7x plus 2. So let u equals 7x plus 2. Then the outside function y becomes, so y equals, so 7x plus 2 is u, so this becomes u to the fifth. Now what we do next is we'll differentiate this inside function with respect to x. So we find du over dx, and that gives us just 7. And then here we'll differentiate this one with respect to u. So we do dy over du, and that gives us 5u to the fourth. Now, using this chain rule, our goal is to find dy over dx. So dy over dx equals dy over du times du over dx. So basically this is equivalent because if we cancel out du, we have dy over dx. That's why this works, okay? Now let's go ahead and do the substitution. So dy over du is 5u to the fourth times du over dx is 7. Now we don't leave it here because our function is not in terms of u. We just made that substitution. So what we need to do is we need to put our function, our derivative back in terms of x. So we'll go ahead and back substitute that u, which is 7x plus 2. So this becomes 5 times 7x plus 2 to the fourth times 7. And then we can just clean this up. We can multiply 5 and 7, which gives us 35 times 7x plus 2 to the fourth. Now this is using the first version of that chain rule, and it looks like a little bit lengthy. Okay, so is there a way that we can do this a little bit in a shorter way? And then the answer is yes. If we use the second version of the chain rule, this work becomes a little bit shorter. Okay, now this is how we are going to use the second version of the chain rule. Let me do that over here. Okay, so we have y equals 7x plus 2 to the fifth power. Now when you're doing this second version, we need to figure out what's the inside function. So inside function is 7x plus 2. Now what is the outside function? It is that we have that parenthesis, so it is just like x to the fifth. Okay, so this parenthesis to the fifth. So when we are using this second version of the chain rule, the first step, we really don't worry about what's inside that parenthesis. What is the inside function? We really don't care. We just look at the outside function. So if you just hide that 7x plus 2, what we see here is we see something raised to fifth power. Now we will use the power rule for this outside function, okay? So remember what I said, the derivative of outside function or the outer function times derivative of the inside function. Okay, so that's what we are going to use. So the derivative of outside function, the outside function is x to the fifth, that parenthesis to the fifth. So if you are confused, this is how you can write this. So dy over dx equals, so that 5, so we have something raised to 5, so that means 5 comes down, then that's something raised to fourth power. So that's the derivative of outside function. But what is inside that parenthesis, we'll just copy that as it is. We won't change anything. So we'll just write that as 7x plus 2. Okay. Now times, so that's the derivative of outside function, times the derivative of inside function. Our inside function is 7x plus 2, and we know the derivative of 7x plus 2 is just 7. Now if you multiply 5 and 7, then that gives us dy over dx equals 35 times 7x plus 2 to the fourth, and that is the derivative. So this one is a little bit, shorter in terms of doing it. So we'll basically use the second one. We'll not use the first one, but they are equivalent. Okay. So let's look at another example. So now let's go ahead and use this second version of the chain rule. So dy, so this gives us dy over dx equals, again, this is the inside function, which is this long polynomial function. And then the outside function is just this power, okay? So that means we can write this as, so the derivative of something raised to 8 is 8 times something raised to 7. So we lower the power, we reduce the power by 1. So that means the inside function, we don't change it, we just write it as it is, which is 2x plus 1. And then times the derivative of inside function. So the derivative of this function right here is 9x squared plus 2. Now we can distribute this 8 to the second. No, we cannot distribute it here because we have that exponent. So we can distribute this 8 to the second term, and then we'll rewrite this as dy over dx equals, so we have 3x cubed plus 2x plus 1 to the 7th power times, so if you distribute that 8, that becomes 72x squared plus 16, and we'll just leave it here. Let's look at another example. Now here we have trigonometric function. Just be careful with this power of trigonometric function, because there's a difference, if we write cosine to the fourth x, and if you write cosine x to the fourth, these two things are totally different. Okay, this means cosine x to the fourth power. This means that power is only for x. So this is cosine of x to the fourth. This is cosine x raised to the power of 4. So this one is, you are taking the function and you are taking the fourth power of the function. But here you have a function with the power of x is 4. Okay, so just know the difference between them. Okay, so if you look over here, the first one we have cosine x to the fourth. That means we can write this as y equals, just to make it a little bit easier for us to see, we'll do this. Okay, now our inside function is cosine x, the outside function is the power function with a power of 4. Then the derivative becomes, so dy over dx. So the derivative of outer function, so outer function raised to 4th, so that becomes 4 times whatever that raised to third. And this is cosine x. Now what we need to do is we need to find the derivative of inside function, and the derivative of inside function, which is cosine x, is negative sine x. Now if we just clean this up, this looks like dy over dx equals, so let's put these two together, so negative 4 sine x times cosine cubed x. We can write it this way, okay? Now this one is a little bit different, as I told you earlier. So this one x to the fourth power. So this here the outside function is sine, and this is sine x to the fourth power. So the inside function is x to the fourth. So first we'll find the derivative of outside function. So the outside function is sine here. So dy over dx equals, the derivative of sine is cosine. So cosine x to the fourth times the inside function is x to the fourth. So the derivative of x to the fourth is 4x cubed. And that gives us dy over dx equals, we can write that as 4x cubed cosine x to the fourth. Okay. Now let's look at another example. So here, the first function that we have here is square root of 3x to the fourth plus 6x. So let's go ahead and rewrite this. Okay, so let's write y equals, instead of writing that way, we can write 3x to the fourth plus 6x to the 1/2. So let's change that square root into an x1 and a 1/2. Now again, the same thing. The inside function is this function right here. This is the inside function. Outside function is a quantity raised to 1/2, or x to the 1/2. Okay, so this gives us dy over dx equals 1/2. So we bring that exponent down here, 1/2 times whatever you have inside that. We don't change it. So the inside function is still as it is, to the negative 1/2, because 1/2 minus 1. Then times the derivative of inside function, which is 3x to the fourth, so it's 12x cubed plus 6. Now let's just simplify this, clean it up and make it nice. So 1/2, we can distribute that to the second one. So 1/2 times 12x cubed plus 6 gives us 6x cubed plus 3. And then this has a negative exponent. So remember, a to the negative m can be written as 1 over a to the m. That means we'll put that down in the denominator. So that becomes 3x to the fourth plus 6x to the 1/2. Or we can write this as dy over dx equals 6x cubed plus 3 divided by, instead of writing the power of 1/2, we can write a square root of 3x to the fourth plus 6x. And then that is the derivative. Now here, let's look at the second question that we have here. Again, this is y equals 2x squared plus over x plus 1 raised to the fourth power. So our inside function here is 2x squared over x plus 1. So dy over dx equals, so 4 times 2x squared over x plus 1 to the third times, now we have to find the derivative of inside function. Now if you look at the inside function, it is a rational function, so we have to use the quotient rule. So remember, the derivative of quotient rule is denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared. So that's what we are going to use, okay? So denominator is x plus 1 times derivative of numerator, which is 4x, minus numerator, which is 2x squared, times derivative of denominator, which is just 1 because we have x plus 1. So derivative of x is 1, derivative of 1 is 0. Okay, over x plus 1 squared. Now let's go ahead and simplify this one. Okay, this looks a little bit complicated expression here. So we have 4 times. Now let's distribute this cube for the numerator and denominator. So if we put it here, so 2 cube is 8, x squared to the third is x to the sixth, divided by x plus 1 cubed. So I just separated the numerator and denominator, times, let's go ahead and multiply this. So when we multiply this, we get 4x squared plus 4x minus 2x squared divided by x plus 1 squared. Now the numerator becomes, so this is dy over dx, dy over dx. Okay, so 8 times 4, so we have 32 x to the sixth times, so we have 4x squared minus 2x squared, which is 2x squared plus 4x, that's the numerator, divided by denominator, we have x plus 1 to the third times x plus 1 to the third, which is x plus 1 to the fifth. Now finally, we get dy over dx equals, so if we multiply that, we can leave it here in factor form, but let's go ahead and multiply. So if we multiply this, we get 64 x to the 8th plus 128 x to the 7th divided by x plus 1 to the 5th. So that is the derivative. Okay. Now let's look at a few more examples. So this one has, actually this one has 3 functions here if you look over here. So the outside function is e, then if we move on, the inside function is this one, and then it's raised to the power of 2. So we actually have 3 functions. So we have to go 3 steps with the chain rule, okay? Now again, we'll start with the outside function. So the outside function is e. So we know the derivative of e to the x is just e to the x. So dy over dx. So the derivative of e to the something is just e to the something. So we'll write that e to the x squared minus 3x plus 5 squared. Now we move one step inside. The next function is this raised to the power of 2. Okay, so x squared minus 3x plus 5 raised to the power of 2. So for the derivative of that one, the innermost function, we'll leave that as it is and we take the derivative of this power function. Okay, so the derivative of that power function is 2 times x squared minus 3x plus 5 raised to the power of 2 minus 1, which is 1, but we're not going to write that. Okay, so we'll just don't write the power of 1. So we'll leave it there. Now, the third step, the third function is this inside function, which is 2x, so the derivative is 2x minus 3, okay? And then let's see what we can do just to clean this up. So that gives us dy over dx equals, so we cannot do anything with the first one, we just leave that as it is, but we can distribute these two either here or here. So I'll just distribute this 2 over here, okay? So if I do that, so I get 2x squared minus 6x plus 10 times 2x minus 3 times this exponential function, which is e to the x squared minus 3x plus 5 squared. So we cannot simplify further, we'll just leave it right here. So that was e. Now let's look at this next question, which is f. So f is y equals cosine of e to the sine squared x. So again, we have 3 functions here, 3 compositions, okay? So the outer function is cosine, so dy over dx equals, derivative of cosine x is negative sine x. So derivative of cosine is negative sine, and then we don't change anything what is inside, we just leave it as it is. Now, if you move inside, e is the next function. So the derivative of e is just e raised to something is just e raised to something. So e raised to sine squared x times, now we have to move inside. Now the next function is sine x. So this sine x is sine x squared. So that means we'll find the derivative of sine x, this power function first. So which is 2 sine x times, then we find the derivative of sine x, which is negative cosine x. Sorry, the derivative of sine x is cosine x. I don't know why I wrote negative. So it is cosine x. Now, let's clean this little bit. We cannot do much, but what we can do here is we have this negative sine e to the sine squared x times e to the sine squared x. So now here we have 2 times sine x times cosine x. If you remember that from trigonometry, we have an identity. 2 sine A times cosine A equals sine 2A. So if you remember that double angle identity, we can write that as sine 2x, okay? And then we'll just leave it here. We cannot simplify further. Now let's look at this for this question where we have to use the product rule and chain rule, both, okay? Before I start doing the derivative, let's rewrite this function as y equals x squared times x squared plus 1 to the 1/2. So let's change that square root into an exponent. Now let's go ahead and find the derivative. So dy over dx. So we have to use the product rule first. So which is first function derivative of second plus second function derivative of first. So your first function is x squared times the derivative of second function. We have to use the chain rule here. So the derivative of this function is 1/2 x squared plus 1 to the negative 1/2 times the derivative of inside function is 2x, okay? Then plus, so this is first function derivative of second. We just did that. We use the chain rule for the second function. Now plus second function, which is x squared plus 1 to the 1/2 times the derivative of first function, which is 2x, okay? Now let's go ahead and simplify this. So that gives us dy over dx equals, so here we can cancel out these two and this two. And then when we distribute that x cubed, this is what we are going to get, okay? So x squared times x, we get x cubed. Now we have this negative exponent. So we'll put this under that x cubed or in the denominator, which is x squared plus 1 raised to 1/2, but it is same as saying square root of that, okay? Now plus here we have 2x times the square root of x squared plus 1. We can leave it here, but it looks like we can combine this one, make the common denominator and then combine it. So in order to make the common denominator, I have to multiply the second term by the square root of x squared plus 1. So multiply the bottom by x squared plus 1, the square root of x squared plus 1, and I have to do the same thing in the numerator. So multiply by x squared plus 1. Now we have the common denominator here. So the common denominator is dy over dx equals, which is square root of x squared plus 1. And then we have x cubed plus, so here we have 2x times, so when we multiply this square root of x squared plus 1 times the square root of x squared plus 1, that is just x squared plus 1, okay? And then let's go ahead and simplify this. Dy over dx equals, we have x cubed plus 2x cubed plus 2x over square root of x squared plus 1. Or finally, if we combine the like terms, we get 3x cubed plus 2x divided by square root of x squared plus 1. And this is the derivative of that function, okay? Now I showed you so many examples with the chain rule. Now here is a try now problem. You can pause the video, try this problem on your own, and then you can verify your work, okay? Let's go ahead and do it now. So dy over dx, again, this is the inside function. Outside function is the power function with a power of 7. So what we do here is we bring that 7 down times sine cubed x plus 3 sine x plus 5 to the, so 6. Now that's the derivative of this outside function times the derivative of inside function is, so derivative of sine cube x is 3 sine squared x times the derivative of sine x, which is cosine x. Then plus derivative of 3 sine x is 3 cosine x, and then derivative of 5 is just 0, so we just have that one, okay? So I can distribute the 7 into the second term because I don't have a power for the second term. So I can write this as dy over dx equals sine cubed x plus 3 sine x plus 5 to the sixth times. So if I distribute that 7, I get 21 sine squared x cosine x plus 21 cosine x. So that is the derivative. Now let's look at this last problem in this video where we are going to use this table to find the derivative of the composition function, okay? So this composite function here, h of x equals, so we have h of x equals f of g of x. Now if we find the derivative of this function, h prime of x equals the derivative of outside function, which is f prime of g of x, times the derivative of inside function, which is g prime of x, okay? So that's the derivative. Now we are asked to find the derivative of h at 1 and derivative of h at 2 using that table, okay? So let's do the first one. The first one that we have is h prime of 1. That equals, so if we put it here, we are going to use this is the derivative of h, okay? So we are going to use that one. So that becomes f prime of g of x, but x is 1, times g prime of x, which means g prime of 1. Now we'll use this table to find these values, okay? So f prime of g of 1 means g of x at 1, the value of g at 1, or when x is 1, is 2. So that means g of 1 is 2 times g prime of 1. Again, if we look that at the table shows us that g prime of x at 1 is 3. So that is 3. Now we have to go one more step. Now this gives us f prime of 2. Okay, so the derivative of f at 2 is 7 from the table. So this is 7 times that 3, and that is 21. Now let's look at the second one that we have, which is h. So the second one is h prime of 2. Again, same thing, that if we put it here, so f prime of g of 2, because x is 2, times g prime of 2. Now look at the table. So f prime of, so g of 2 means the value of the function g at x equals 2. So g at 2 is 1. So this is 1. So f prime of 1 times g prime of 2 means the derivative of g at 2. So the derivative of g at 2 is 4. So we put 4 here. Now the second step, the next step is we have to find what is f prime of 1. So f prime of 1 is 5. So this is 5 times 4, and that gives us 20. So that is the derivative, and this is for the first one. That's all for this video. I'll see you again in the next video.